Hey everyone, and welcome to another video. Today, we are diving deep into the fascinating world of cryptography and ethical hacking on Kali Linux. We will be taking a comprehensive look at a highly specialized tool known as the ClatSecure Encryption Key Generator. In the modern landscape of cybersecurity, understanding exactly how encryption functions under the hood is absolutely critical. It is not merely about penetration testing, it is about fundamentally knowing how data is mathematically protected so we can secure systems and audit algorithms in a strictly ethical way. ClatSecure is an excellent Python-based educational utility that implements Advanced Encryption Standard key generation and encryption utilities right from your command line. Let us start with an overview of what this project actually accomplishes. The ClatSecure script is designed to handle secure key generation and complex encryption round functionality. It supports multiple tiers of encryption, specifically 128-bit, 192-bit, and the military-grade 256-bit AES encryption keys. What makes this tool truly remarkable is its implementation of Argon2I for key derivation. Argon2 is a memory-hard algorithm, which means it is heavily resistant to brute force attacks from graphics processing units. This makes our derived keys incredibly secure and highly resilient against modern hardware-accelerated cracking attempts. The tool also provides granular insights into the AES key expansion process and encryption round functionality, including substitution box, round constant, and exclusive OR operations. Before we boot this up in the terminal, let us break down how this script operates mathematically. The process is divided into three main phases. The first phase is key derivation. Instead of using a human-readable password directly, the script derives complex cryptographic keys from your password using the Argon2I algorithm, combining it with a securely generated 16-byte hexadecimal salt. This salt ensures the resulting keys are completely randomized yet mathematically reproducible for symmetric operations. The second phase is AES key expansion. The generated key undergoes an intricate expansion process to create a complete schedule of round keys. This involves RCON, which acts as the rounds constant, and S-box operations, applied to create vital nonlinear transformations. These nonlinear transformations are what make AES famously resilient to cryptanalysis. Intermediate keys are then XORed against each other to create the expanded keys for each round. The third phase involves the actual encryption rounds. The state matrix is transformed through a rigorous repeating sequence. First is the subbytes step, substituting bytes using the nonlinear AES S-box. Next is shift rows, where the rows of the state matrix are cyclically rotated to scramble the data structurally. Then comes mix columns, combining the columns mathematically to provide massive diffusion. Finally, the add round key step occurs, where the current state is XORed with the specific round key generated during the expansion phase. All right, let us move on to setting this up. Since we are operating on Kali Linux, the installation process is straightforward, but we need to ensure we have the precise dependencies required for these matrix operations. The ClatSecure tool relies on a few specific external Python libraries. It uses the built-in operating system library for generating highly secure random salts. We also absolutely need the NumPy library. NumPy is mandatory because AES encryption relies heavily on complex matrix manipulations and mathematical transformations, which NumPy handles with incredible efficiency. We also need the Argon2 CFI library. This is the powerhouse behind our cryptographic key derivation, allowing us to safely transform standard passwords into high-entropy keys. Finally, we need PyStyle, a great aesthetic library used for terminal branding, giving the script a clean, professional visual output. To install these dependencies, open your Kali Linux terminal. Type the exact command pip install numpy argon2 cfi PyStyle and hit enter. the terminal will immediately begin fetching the required packages. It will download NumPy, gather the requirements for Argon 2, and pull in PyStyle. Once the terminal clears the download queues and returns to the standard commands prompt with a successful installation message, our machine is fully prepped and ready. Now let us actually showcase the tool in action. I will navigate through the file system to the directory where I saved the ClatSecure script. For this demonstration, we are going to execute the maximum security 256-bit version. In the terminal, we will type Python 3, followed by a space, and then the file name ClatSecure 256bit.1.03.py and hit enter. Immediately, the terminal lights up with the vibrant ClatSecure branding. The interface is clean and prompts us right away to enter our target password. I'm going to type in a strong, complex passphrase for this demonstration. Notice that the moment I hit enter, the script immediately goes to work processing the cryptography. First, it outputs the randomly generated 16-byte hexadecimal salt. This visual confirmation guarantees that even if two users utilize the exact same password, their final encryption keys will look completely different. Next, you can see the terminal outputting the Argon 2I hashing process details. It takes our plain text password, securely combines it with the salt, and pushes it through memory-bound iterations to derive the initial raw cryptographic key. Now, the script transitions smoothly into the AES key expansion phase, outputting the underlying matrix transformations in real time. You can see the initial state matrix being formed. Watch closely as the script systematically logs the sub-bytes substitution, showing exactly how our initial values are being swapped out based on the AES box. Next, the terminal displays the shift rows output, visually tracing the byte positions shifting across the matrix. Then, it actively processes the mix column step, mathematically tumbling the data once more. Finally, the add round key step successfully completes the first round, XORing the state with the newly expanded key. Because we're running the 256-bit version, this rigorous process loops through 14 separate encryption rounds. At the very bottom of the terminal output, the script cleanly presents our final, mathematically secure 256-bit AES encryption key alongside the final encrypted hexadecimal state matrix. It's a brilliant, transparent way to visually understand the heavy mathematical lifting of modern data encryption. And there you have it, a complete ethical walkthrough of the ClatSecure Encryption Key Generator natively on Kali Linux. Understanding the step-by-step matrix transformations of the Advanced Encryption Standard combined with Argon 2I key derivation is an absolutely fundamental skill for any serious cybersecurity professional. I really hope this practical demonstration helped demystify exactly what happens dynamically during key expansion and complex encryption rounds. Thank you all so much for watching. Keep exploring the math behind the tech, and I will see you all in the next video.